Okay, welcome back to the next section here. And so in this section, we're going to start doing some coding because it's always good to get into that early, and then it also just gives us the quickest opportunity to actually do something in our game, so our game actually does something rather than just sits there and does nothing. Because the vital part of the game, obviously, is that it actually does something. So with this in mind, we're going to go click on our spaceship. Actually, we're not going to click on a spaceship. We're going to make a folder first in our project view. And so to do that, we just go right click on it. We're going to go create. And on the very top, we're going to go folder. And we're going to make a nice scripts folder here. We're going to click into that. We're going to right click again. We're going to go create. And this time, we're going to go C# script. If we click that, it'll prompt you to name this thing. And one thing that's important while naming this is that if you name it incorrectly, just delete the script when you set it up initially, because it does some things in the background depending on what you name it. So just, if you don't get it right the first time, just delete it and reset it instead of renaming it. It'll cause you less trouble later on. But what we're going to call this is player. Ideally, if you follow along exactly what I say right here, it's going to be easier on you, but you can name it whatever you want. It just will be harder to follow along later on. So I recommend calling it capital P player. So you click on that, you open this up. And so yeah, you should be able to just double click on the script and it should open up this Visual Studio community. You might have different color settings than me, but it should be fine besides that. If you've never opened Visual Studio Community before, I'd recommend you clicking on this Visual Studio Community. I think if you're on Windows, it's going to be in Tools, but there's a Preferences section. And then you can open that up, and under Text Editor in Behavior, you'll want to click Insert Matching Brace and Format Document on Save if they're not selected already. They're just going to make coding a lot easier in these environments, so I generally just recommend to do that right away and then save yourself some trouble. If you are interested in changing the colors, what you can also look in here in the color theme, I think, yeah. It's a color theme section under the text editor that you can fool around with and have fun with, but we're not going to go through that right now. So getting out of that, we're going to go now and look at the script. So it already has some stuff in it automatically when we kind of create these scripts. And so first of all, we're just going to take it really easy. We're just going to not look at anything up here. We're just going to mainly look at this little section here. So what you'll see is that there should be a void start with some parentheses and then some curly braces right here. And then there's a void update, some more parentheses, and some more curly brackets. And then there's some comments on the top of here. So by default, anything you write in code that is started off by 2 slashes will just be ignored. So you can write whatever you want after 2 slashes, and it'll be fine. You don't need to care about typing in things correctly. This is purely just to say something for the humans reading the code. The computer will ignore whatever's behind those slashes. And so in here it says start is called before the first frame update. And in addition to this, it's only saying it'll only be called that first time. It's never getting called again. So it's only called once. And then update, above it says update is called once per frame. And if you're unfamiliar with kind of like how what a frame is in a computer sense, it's that every single time the screen updates, that's a frame. So it'll draw one full kind of image, display that, and then that's a frame, and then it'll display another image. You'll often see things called FPSs or frames per second, and that's how often the screen refreshes. And so how many times that does, it'll call this method or this area here. So things will happen. If you put things in here, it'll be called every frame. And if you put things in start, it'll only get called once in the very beginning. Just to illustrate this, I'm going to have you write your first little bit of code. And what we're just going to write is called print with a lowercase p. We're going to put some parentheses out. And if you did the step before where we set insert matching brace, you'll see by just putting in the starting parentheses, it'll automatically insert the second one. So that's good because you'll want two of them there. And then you want to put some quotation marks, which should also put in 2 just by default. And we're just going to type in start here. And then we have to end our line with a semicolon. Just to recap, so we're writing print, and what print does is it'll debug out some text when this thing happens, which I'll show you in a second. And we're just saying it to print out start. And the reason why we put quotation marks on that is just to tell the computer, hey, this is some text that we're writing in. Don't take it literally. Don't try to think this is anything that we're specifically saying is like an action to be called. It's just some text. So that's what we say. This is text, basically, is by putting things in quotation marks. And then I'm also going to do the same thing over in update. We're going to type in print. We're going to type some more parentheses. I'm going to type some quotation marks. And then I'm going to type in update. And then I'm also going to end it with a semicolon. So every single line, pretty much, that we write in code will have to have a semicolon at the end. And that's because just on a computer level, this is perfectly valid, right? So you could write this entire section of code in one line that spans off into infinity, and that's the same thing as actually writing it in multiple different lines. So what the semicolon says is, hey, this section is all I'm writing for this kind of line, and then this section would be the next line. We're not going to write the second start, but that's just kind of how the computer interprets a line is whenever there's a semicolon there, it says, oh, that's the end of the line. Okay, cool, I'll stop there, and then I'll start the next line right after. So always just make sure that you've ended it with a semicolon. So if you have that, you have both print start and print update. You're going to have to make sure that you save it, and you can either do that on Mac is Command S, and on PC it's Control S, and that will save your script. And the way you can also just check that on a gut level is if you have a change, you should see up here there's kind of like this O that happens, and then as soon as you save, it will not have that little O anymore. So the O is just a really easy way to say, hey, have I saved this script or not? You can just check that. If it's not showing an O, then it should be saved. If you have all that, what you're going to want to do is go into Unity and click play. Now, nothing visually will happen in the game view, but if you click on this thing called console over here, nothing will happen yet. And the reason why nothing will happen yet is because we actually haven't added the script to anything. So the script doesn't run by itself. It runs on a game object. So it has to be added to some sort of game object to actually run. So if you click on your spaceship now, we can go add component, we can go player, and find our player script, and click on that. You'll notice the script gets added, and then you can click play, and then we'll actually see something. So that's kind of something I always forget to do when I do this, but yeah, that's the important thing is you actually have to have the script on a game object for it to apply. But what you'll see in console now, that's the important part, is that there's a start text that gets displayed out, but it only gets displayed out once. And then there's an update that's just continuously being thrown out. So you'll see that there's a count here. If you want to see this in just kind of the order that it gets fired, you can always click off of collapse, and you'll see that it just keeps firing up these updates. But in the very, very beginning, there was a start. Okay, and just to talk about the console a little more. So this is generally where all kind of debug logging or any sort of information like that will come in. It'll also display errors in your code. So, for example, if I click unplay here, say I had forgotten to put the semicolon in. The code would actually be kind of trying to warn you, saying, hey, it's expecting a semicolon here. But say you ignored that and you just went over into your game, you'll notice this thing showing up. And this is saying that there's an error. This is a compile error, meaning on the level of compiling, it failed to figure out what your code is trying to do. And if you try to click play right now, it'll come up with this other thing saying, hey, you have to fix these compile errors before you can play, because the code doesn't know anymore what it's supposed to be trying to do. So the useful information here is the first thing it says is that it says that there's the script that we're having an issue with. So it actually says asset scripts player, and then it says this next section, which is 1624, which is the location. So should be the 16th line, and I think it's like the 24th space over is where it's saying this error is occurring. It has an error code, so if you would Google this, it would probably say something to the effect of this. So it's saying, hey, I expected a semicolon, but there's no semicolon. You can either now go over to your editor and say, oh, on line 16, oh, I forgot a semicolon, but you could also just double click on this, and what it should do is it should open up the editor and highlight the specific line that it's saying is an issue. So right now it's saying, hey, there's no semicolon. So you can put that in, save it, and then when it compiles again, you'll notice there's this little kind of thing down here on the bottom, and that's just saying that Unity is compiling. So whenever that thing's showing up, that's just what it's doing. And so now you see that other error disappeared. You'll see this error still stick around, but that's fine. It no longer matters. The way you can kind of tell if your game is ready to go is you can just click the clear. And if everything's cleared off, there's nothing there anymore, there's no error showing, then it's good to go. You're ready to play, and there's no errors. So we should be able to now click play again, and the game will work. All right. So that's kind of the beginning of it. Obviously, this is just text. This isn't very interesting, but it is kind of showing us what these two sections of code do. So the start always just happens once before any of these updates happen, and then the update happens every single frame after that. Now, say we wanted to actually do something in our game. We actually would have to accept some sort of input. So we'd have to know, hey, is a button pressed down? Something like that. And to do that, just as a check to visualize this, instead of writing update, what I'm going to do is we're just going to remove out the quotes of this. So I'm just going to say print, this parentheses semicolon. And instead, what I'm going to type in is input with a capital I. And then I'm going to put a period in. And then I'm going to be typing in get key with capital G and capital K. And this also needs some more parentheses. Might try to put in one less. And then inside these parentheses, we're going to have to type in, I guess I'll just do this one, key code with a capital K and a capital C and one more period. And then we're just going to type in A, capital A. You'll see it starts to kind of autocomplete here. So there's some options that are visualized here. And you have to click down for them to start selecting. But after you click that and you see it's kind of blued, you can just click enter and it'll autocomplete for you. So what this section is doing here is figuring out, is the A key pressed down at the moment? And with that knowledge, it'll give us back something, which we'll see in a second, to kind of tell what that's doing. So this part is check a key if it's pressed down, if it's currently being held down, right? If you hover over this, it'll actually give you some information. And it just says returns true while the user holds down the key identified by the key code parameter. So the key code that we're giving it is A, and so we're just saying that A is the key we're looking for. You'll have to make sure that there's kind of two end parentheses at the end here, because one of them is for the get key section and the other one is for the print. But otherwise, you just make sure there's a semicolon still there. Make sure you save your code. And then we should be able to go back into Unity, and we should be able to see something a little bit different. Still in the console right now, but there should be a little bit of difference in what happens when we play. So if we click play now, you'll see every single frame it's saying false. And this is saying false because when asked, are you holding down the A key? It's saying, no, you're not. So that's false. If we were then to hold down the A key, so I'm holding down the A key now, you'll notice now it says true. So when we're asking, is the A key held down? Yeah, it is. So that's true. So it's like a true or false statement is what it's giving back. If I let go, it turns back to false. Hold it down again, it goes to true. False, true. And this is what we refer to as a bool. So a bool has a value of true or false. And that's what the method in here, input.getKey, is giving back to us. It's telling us either yes, you're holding down the A key in case it's true, or no, you're not holding down the A key in case then it sends us back false. And so it's all good for us to just see this text and have it say true or false back to us, but it would be way better, if we actually could do something a little bit more with just that. So the first thing we're going to do here is going to remove the semicolon temporarily, and we're going to replace print with if. I'm going to say if, and then we're going to add a line to the bottom of this and put 2 curly brackets in. So it should kind of look like this. So there should no longer be a semicolon here, and that's just because they're putting these kind of code block curly braces below it. But now we're asking if our input key, so if our input key A is pressed down, if it is, we'll actually do this code section. Otherwise, nothing will happen. You won't do anything inside here unless input get key is down. And just to visualize this, we're going to do one more print statement. I know you're probably tired of text. We're just going to do one more input statement here and saying pressing A. And make sure that's ended with a semicolon. So just to recap, what we've done here is we've replaced that print with an if. We removed the semicolon at the end of here and kind of added 2 curly brackets. And inside those curly brackets, we've placed a print of pressing A. If you go in, all things, and if we were to click play again, you'll see there's a start, but there's no other logs happening. But then if we start holding A, you'll start to see it saying pressing A. So now we've effectively gotten something to only do something when we're holding down the key. So this is the kind of the cornerstone of being able to do something when you press a button, right? And so as long as we're holding down the A key, anything inside this little section here will happen. So let's make it actually do something that's doing something, because right now it's not doing anything, so that's kind of boring. Now, if we were to replace this, so we just delete the whole, the whole print section, and we're going to write some extra stuff. But before we do that, I'm just going to briefly mention about how we kind of indent things here. So you'll notice whenever these kind of curly brackets are in existence, we try to kind of indent once and then start typing our text in, kind of in that line. And then whenever there's one here, what we're going to do again is indent again and then start writing things from this point on. And that's just to keep it clean and kind of understandable so that it's easy to read through. If it were all like on here, it just gets really confusing to read from. Like, it's just kind of hard to read. And by default, if you just save, if you've clicked that format document on save, it should automatically do a lot of the stuff for you. So it should just look a lot nicer like that. If we go into here now, though, we're going to want to do some sort of input. And so or do some sort of movement, for example. So first thing I want you to type is transform, and this is lowercase t, transform. And this is just a reference to that transform component that we saw in our game object here. Because every game object has a transform, the mono behavior that we created, or script we created, just knows there's going to be a transform there. So we can just say transform, and we're going to do a period. So this is accessing something that's on our transform. And we're going to say translate. And that's not like translating as in translating a language. This is referring to a translation. So like is a movement. You're translating something to a different spot. I know that can kind of get a little confusing, but just think of this translate as move. And then it'll probably be a little bit easier to understand. So this translate, we're going to put some of these parentheses up. And then what it's going to ask us is for 3 different numbers. So right now I'm just going to put in 0, 0, and another 0, and then end this with the semicolon. And so just to visualize what these are representing, the first one is the X position, the second one is the Y position, and the third one is the Z position. And if you were to look into Unity, when we are in our scene view, the X, right, is the left and right, the Y is the up and down, and the Z is the one you can't really see, but that's forward and backwards, right? Now, if we wanted to move our thing left, so A is normally referred to as like the left movement in our game. So if we were going to do something where we're moving left, we'd want to use a negative X, right? So if you'll notice here where my guy is positioned, if I start moving this into the negatives, you'll start to notice he starts to move left. And that's just kind of how we know that we want to move left. So if we want to move left, all we have to do is make the X value, which is the first one, because it's X, Y, and Z, we just have to make it negative. So let's just say, for now, -1. And then we save that, and then it should be working. So just to recap what this is doing, is it's getting our transform, it's saying, hey, transform, I want you to move 1 unit to the left. And then you're only doing that if the A key is being held down. So just to visualize this, now we should be able to go to Unity. You can click play. We still get our start, but now if we hold our A key, woo, you'll see we're flying away. If you selected your spaceship in the scene and you hold A again, you'll see that he's just flying away. Okay. That's pretty cool, but 1 is pretty fast. But it's kind of weird because you'd think, oh, well, 1 is pretty small of a number, but it's also going very fast. And that's because update gets called every single frame. And I think by default, it's trying to probably target a 60 frames per second. Anywhere from 60 to 30. So you can kind of range in this, and you can go from 60 units to the left to 30 to 60 units to the left in a single second. And that's actually quite a bit. And we don't want to just make it like a super, super small number, because then that doesn't really explain anything much. But also, we want to know that if we have a game that's running at 60 frames per second, and we have a game that's running at 30 frames per second, say you have a lower-end computer and a higher-end computer, they'd run the game at different frame rates, right? So one might be running at 60 frames, and one might be running at 30 frames. What we don't want is the one person playing at a 60 frames per second is to go twice as fast as the person that's going at 30 frames, right? And so that's what this code currently does, because it is trying to move 1 unit every single frame. So the way we can make this what we call frame rate independent, so not reliant on how fast the computer is that we can times this 1. Instead of timesing by 1, instead of just being 1, we're going to say 1, or -1 in this case, times a thing called time, capital T, period, delta time. And if we hover over this, it'll actually give us an explanation of what this is. It says the completion time in seconds since the last frame. So to explain this a little bit more, if you're running at 30 frames per second, this would be 1/30th of a second, right? So whatever 1 divided by 30 is. It's about like 0.033 continuously, I guess. But if you're running at 60, it would be 1/60. And so this makes it so that this is now, essentially, it's 1 unit per second. Instead of 1 unit per frame, it's 1 unit per second. And if you save that, I'm not sure, I should have probably talked about this. Times in coding is always the star. It's not, don't type an X or anything, it's just the star. So it's shift 8. I know that might not be as apparent if you're not used to this kind of function. So yeah, if you want to have -1, then you do the star, which is equivalent to multiplying, so timesing, and then timesing time.delta time. And that will make this movement equivalent to moving 1 unit to the left every second. And if we go into our game, we should be able to now see that. So we click over here, and we click play. And if we hold A, we're now moving at 1 unit per second. Like you can see, 1, 2, 3, 4, 5. Right? It's moving at pretty much 1 frame a second, which is what we want. Now you're probably thinking, though, 1 frame is 1 unit is kind of slow. Like that's pretty slow. That's kind of painful. So you might be thinking, oh well, let's just change it to something like 5. That's cool. That's good. But the problem with that is then, okay, you've written at 5, you'll have to click now and save, you have to go back into the game and compile. And then you have to test it to see if that works, and see if you like it. But then maybe 5 is just like too fast, so maybe you're going to like 4, and then maybe 4 is alright, but maybe you might want to try like 4.5 now, or something like that. And it would be a lot better if you could just do all that kind of number changing in Unity, right? So at this point, what we want to do is change, instead of just saying 5 here, we would want to be making this a variable. So it's something we can actually expose out into the Unity side of things and change there, and this would automatically be reflected in this section of code. So to do that, what I'm going to do is we're going to want to, you click right behind this kind of curly brace here in player, and we're going to click enter. And so then you should have a line that's right before the comment and kind of underneath this curly brace. And what we're going to want to type here is public float speed equals 5. And then make sure you have the semicolon on the end of that. And so what this line is saying is that we're declaring a public variable, which means it's viewable kind of outside this class that we've created, but it also means that that's not as important as right now, that this means it's going to be viewable in Unity. So we'll be able to actually edit this on our little mono behavior that we've created, our little component. And float, which means a floating point number, or in other words, it's a number that has a decimal point, or the number that can have a decimal point. So numbers like 3.5 are acceptable, or 3.621, something like that. Like all those numbers are fine because it allows a decimal point to be in the number. Next part is speed. So this is whatever you write it as. This is the name of your variable. So you can name it whatever you want, but I just recommended calling it speed because it'll probably be easier to follow around with me if you just call it lowercase s speed. And then we're saying that it's going to be equal to 5. So we're just saying that this value will have a default value of 5. Okay? And then of course we're ending it with a semicolon so that the compiler knows that, hey, that's the end of the line. Now if we wanted to actually use this in our speed as our calculation of update, we're going to take speed and we're going to put it instead of the 5 here. So we're going to leave the minus because we'll want it still going in the negative direction. We're going to be wanting to go left, right? But we'll just put in speed right here. And so now what this on the computer level is saying, hey, this is a negative value of speed, which is equal to 5. So it's negative 5 times our delta time. So now we've made it so that we have this variable instead of just a hard-coded number that we've written on our line there. So if we were to click Save and go back into Unity, before we let it play, just let it compile first. So it should be compiling. Yeah, it's done. And you'll notice on our little player script that we've made here, there's now the speed variable, right? And it's equal to 5. And so if we were to click play now, we can click A and we'll be moving. But if we were to click and set speed to say 1, we'd start moving slower again. So this is dynamically changeable. You'll notice as well though, as if I go out of play mode, it'll go back to 5 because 5 is the default. But you can change it here to something like 10, and that's fine. It'll save that value when you go into play mode and won't get reverted. Right, so that's now your speed, how fast the player moves. Right, and so the only other important kind of thing to note here is we've set it to 5 here. The code isn't changing though. It's always going to say 5. And this is essentially what we've written by saying equals to 5 is just, that's the default value. If we go into the editor and we change it, it'll keep that value that we've changed in the editor. But now say if we went and made this like, I don't know, 3 or something, and saved that, it wouldn't force this this game object here to have a new value. It would still stay at 10 because we've modified it on this object. So we wouldn't want to kind of replace that over top of it if we just change the number. That'll keep it so that we are allowed to modify it, and it kind of keeps its value when we've changed it. Okay. So now we've done that. All we have to do now is just give it multiple ways of movement. So we've got the left going, but I would challenge you right now, don't keep playing it, pause it, and try to do all the other directions by yourself. If you can do that, it's really great. I'll kind of pause it here, and then I'll come back and we'll show you the kind of completed version of it. Okay. So now you'll see that we have an if statement for each direction. So there's if k for A, which we've already written, but I now have one for D, and the only thing that's different here is that we changed it from negative to positive, and then we've set 2 other ones, one for W, and that's going up, as the normal convention goes. So we've changed it, instead of being in the first category for X, we put it in the second section for Y, and we've made that positive because we want to go up positively. And then I actually forgot to add the negative sign here. But for S going down, we're going to write negative speed because we're going to go negative on the Y. If we save this up, we should be able to go and click play. We should now be able to move in all directions. Should also handle pressing both buttons pretty well because they'll just counteract each other. So if you press both like A and D, they'll just kind of keep you stable in the same spot. But you should be able to actually now move your player all around. You can also move them outside of the screen, but we're not going to fix that for now. We'll fix that in a later lesson. Okay. Awesome. Hope that was easy for you guys to get, and it's kind of fun to do because I think it's pretty cool to have this actual visualization of your spaceship moving. I think that's pretty cool to end it off on it. But that's going to be the end of this day's lesson. And I'll hope to see you guys in the next classes and the next videos. Thanks.